So in this video, we will learn more about what a series is and what it is kinds, examples, and we will discuss about how it can be applied in.
So in this presentation, we would like to find what the definition and discuss what a series is. And at the end of this presentation, we hope that you will learn and fully understand the value of a series. We would also discuss about the kinds of series. For examples include arithmetic, which is the most common of the series given, geometric, and also alternating series. So the picture that you can see on this slide is an example of a series. Let me just highlight that part. So, are you ready to go now to the world of series? Come on, let's go! So let's begin. So what is a series? A series is the sum of all terms found in a given sequence. You can say that a series is a summation, but a summation is not a series. A summation will be discussed in further videos. So now we will go on to the kinds of series. Now, as presented in the video, there are three types of series. These include the arithmetic series, the geometric series, and the alternating series. So the first kind of series is the arithmetic series. So what is an arithmetic series? An arithmetic series is a series with a common difference, mostly presented with the variable d. The lowercase d is used in formulas rather than the uppercase d. Here you can see the formula of the arithmetic series. So you can see that it is S sub n, where n represents the number of terms. The a sub 1 represents the first term, and a sub n refers to the nth term. So the formula is S sub n is equal to n over 2 times the quantity of a sub 1 plus a sub n. Let me give you an example. So here we have a given sequence in which 2, 4 up to 8. So as you can see, it has a common difference of 2. By using the formula given earlier, we can say that we have S sub 4 is equal to 4 divided by 2 times the quantity of 2 plus 8. By solving the operations found in the parentheses, we will have S sub 4 is equal to 2 times 10, and simplify we'll have S sub 4 is equal to 20, which is our final answer. So let's try to apply the arithmetic series in real life. So here we have a word problem. So the problem is, Galileo started her job that pays weekly. She gained $4 on her first week, 7 on her second, and 10 on her third week. So how much money did she make? You can try to pause the video and try to solve the problem yourself. So I will give you a few seconds and I will show you the solution. So here we have the solution. So the given terms in the problem is 4, 7, and 10. So we can say that the common difference is 3 and the 10 is a third term. So using the formula, we'll have S sub 3 is equal to 3 divided by 2 times the quantity of 4 plus 10. So we can simplify that and we'll have S sub 3 is equal to 3 divided by 2 times 14. After that, we'll have S sub 3 is equal to 42 divided by 2, and solve for the answer, we'll have S sub 3 is equal to 21, which is our final answer. So, did you able to get the answer? If you did, well, that's great. But if not, well, better try again. So now we will move on to the next kind of series, which is the geometric series. So what is a geometric series? A geometric series is a series with a common ratio, mostly presented with a variable r. Similar to the arithmetic series, the common ratio is mostly denoted by the variable lowercase r rather than the uppercase r. So we will move on to the formula. The formula in the geometric series is almost similar to the arithmetic series. It also have the variable n, which signifies the number of terms, a sub 1, which is the first term, and we will now have the variable r, which is the common ratio of the given sequence. So the formula is S sub n is equal to a sub 1 times the quantity of 1 minus r raised to n over 1 minus r. So here we have another example. So we have the geometric sequence 2, 4 up to 16, in which 16 is the fourth term. By using the formula given earlier, we'll have S sub 4 is equal to 2 times the quantity of 1 minus 2 raised to 4 over 1 minus 2. So let's try to solve the numbers within the parentheses, and we will have S sub 4 is equal to 2 times the quantity of 1 minus 16 over 1. Then we'll have S sub 4 is equal to 2 times the quantity of negative 15 over negative 1. Then let's multiply the numerators, and we'll have S sub 4 is equal to negative 30 over negative 1, which is similar or equal to S sub 4 is equal to 30. And 30 is our final answer. So let's try to apply the geometric series in real life. So here we have again a word problem. So here we have Mongol, which is a scientist. So Mongol discovered the bacteria that triples its population every day. So what will be its population after 4 days? Again, you can pause the video and try to solve for the answer. So here is the solution to the word problem. So let's try to assume that the starting point of the population of the bacteria is 1. So our a sub 1 will be 1. So let's move on to the formula. So we will have S sub 4 is equal to 1 times the quantity of 1 minus 3 raised to 4 divided by 1 minus 3. By simplifying the numbers within the parentheses, we will have S sub 4 is equal to 1 times the quantity of 1 minus 81 divided by negative 2. By solving the numbers within the parentheses, we will have S sub 4 is equal to 1 times the quantity of negative 80 divided by negative 2. By multiplying 1 and negative 80, we will still have negative 80. So next will be S sub 4 is equal to negative 80 over negative 2. So simplify, and we will have S sub 4 is equal to 40, and 40 is our final answer. So it's pretty easy, isn't it? So you can find the sum of any sequence by just using the formula. So by using the formula is pretty nifty rather than trying to solve each term by adding or combining against it. So the last kind of series that we will discuss is the alternating series. So what is an alternating series? An alternating series is a series with the terms have continuously alternating signs. So the sequence will mostly start as positive, then it will come to negative, or it will start as negative and it will become positive, and so on and so forth. So here we have our examples. I didn't add the formula because I think it is easier to just combine each term with each other rather than finding the formula, which is very complex. So in the first sequence, we will have 1, negative 3, 5, negative 7, then 9. So by adding those terms, we will have S sub 5 is equal to 5. So the second sample sequence is 2, negative 4, 6, negative 8, 10. So by just combining all those terms all together, we will have S sub 5 is equal to 6. So that is the end of the presentation. I would like to thank you for listening. I hope you learned a thing or two, and I guess I will see you then.